Okay, if we have a look at what we've got here, question 5, this is a question about a separating technique, and you should recognise the apparatus that's been set up because you will have seen this a few times in school. Okay, the apparatus has been set up and we're told that it's being clamped safely. That's quite important for later on. And then it was used to separate alcohol from water. Right, firstly we have to name this process. And looking at it, you'll probably, hopefully, automatically think distillation. But what I want to draw your attention to is the presence of this column here. Okay, that column, you can see the little lines inside it, look. Okay, so something's inside that column. And when we add that piece of apparatus in, that's a fractionating column, we call it fractional distillation. Okay, so that should be the correct name. Okay, simple distillation will not have this column here. Okay, it's just you get the top of the round bottom flask directly connected to this piece of equipment here. Right, why can the alcohol and water be separated by this method? So why? It's only 1 mark, so we don't need lots and lots of detail. But when you've got these two liquids mixed together, the reason they can be separated by this method is because they have different boiling points. Okay, so their boiling points are different. Okay. That means that one of them will boil first and will turn into a gas and start to move up this tube here and eventually reach here and start to move down. Okay, whoops, didn't mean to do that. Let's try and get out of it. There we are. Okay, name the apparatus labelled X. So X is over here. We've got a piece of apparatus I'm pointing to. That's where condensation happens. The gas turns back into a liquid. So it's called a condenser. And that would be okay for an answer, but actually to give it its correct name, it's a Liebig condenser. And I'm just going to make sure I spell this right. I-E-B-I-G. Okay, that's its correct term because it has water running through it. It has a water jacket, and so we call it a Liebig condenser. Okay, we have to describe one mistake in the setup of the experiment. That's why I drew your attention to the clamped safely at the top here earlier, because a couple of people's answers I read were talking about the fact they didn't think it was clamped very well. Okay, but we're told it's clamped safely, so we've got to look for something different that we can see. And what hopefully you can spot is you've got water going out here and water going in there. And if you remember from when you were showing this in your lesson, they were actually the other way around. The water comes in at the bottom and flows along the condenser like that and comes out the other side. Okay, so the mistake is that the water flow is the wrong way round. Okay, let's just get that in. Okay, and then the last question, why is an electrical heater being used rather than a Bunsen burner? And the reason is that if we think about what we're trying to separate, we've got water and alcohol in there, and alcohol is flammable, so you wouldn't want an open flame. Okay, so the reason that you need to think about is that alcohol is flammable. So it would be dangerous to use the Bunsen burner. Okay. I'm done, Brian!